So, assalamu alaikum everyone. Without wasting a minute, brief revision, and then what else we will do? Some intro of chapter number 4. I should say that the revision will not be so brief. I will spend around 15 to 20 minutes on it, and whatever you have done in chapter number 3, the last part especially, I will focus on it. Bohr's model, you know. The electrons revolve around the nucleus in various shells. The capacity of each shell is fixed. First shell can hold how many electrons? 2 electrons. Second 8, 18 and 32. So you should remember that how many electrons can be accommodated in each shell. So might be you already know it, whatever I'm going to explain right now, because I have done it 2 times earlier. Okay? And let's see, suppose we have a question. What is the question over here? Find out the atomic number you can say it's a model question. Okay? Atomic number, mass number, number of protons, electrons, and neutrons, and the electronic configuration of, very simple one, sodium 1123. So we have a symbol over here, sodium 1123, and we are going to find out its atomic number, its mass number, number of protons, electrons, neutrons, and electronic configuration. As I said, might be you already know it, but I want to wind up chapter number 3 in a healthy way, in a positive way. That is why I am doing it here again. Even then, if you have any question afterwards, you can ask. Okay, well, atomic number. So, the symbol is sodium 1123. So I think you remember the smaller number always represent what? The atomic number. So if I ask, what is the atomic number of sodium? You should say this atomic number is 11. So I'll write here the answer of the very first one. Atomic number, writing briefly over here. Atomic number represented by which letter? Correct. By Z or Z. So what is the value of Z? 11. And the mass number. Mass number is represented by capital A. We have found the second one also. Right? Such type of question will be there in your test. That you will be asked question like this. This could be different. Okay? So with the help of this, we have found out the atomic number and the mass number. Next, number of protons. All of us know that number of protons always equal to Z value. What is the Z value over here? 11. It means protons are 11. It means how many protons are here? 11. And we also know that a neutral atom, what do you mean by neutral atom? Neutral atom means there is no charge on that atom. For example, this is neutral. This is neutral. This is neutral. This is neutral. But if you see a charge on it like this, it will not be a neutral. It will become an ion. Similarly, if we have a charge over here, could be positive or could be negative. These two will be called now ions. These are not neutral. Neutral means no charge at all. So in this case, only this one is neutral. Let me ask, what do you call a positively charged ion? Cation. And what do you call a negatively charged ion? Anion. Cation, anion. So what is the point that we are discussing over here? That if there isn't any charge on an atom, it is neutral. Okay? So here we don't see any charge over here. No charge. It is neutral. So when the atom is neutral, it means protons and electrons are equal. As many as electrons as protons are there. Okay, you did it. So number of electrons represented by number of electrons is equal to protons over here means 11. So what is the bottom line here? For a neutral atom, the atomic number, the proton number, the electron number, all are same. Right, is the assignment also. And how can you find number of neutrons? How can you find number of neutrons? Correct. Subtract Z from A. Or subtract a smaller number from the bigger one. 23 minus 11. It will give you what? It will give you 12. So number of neutrons becomes 12. So we found protons, electrons, and neutrons. Now what is left only? Electronic configuration. What is left only? Electronic configuration. So I'll write the heading here. Electronic configuration. Okay? Okay, let's continue. Electronic configurations. Number of electrons we have here. How many electrons do we have? 11. Okay. So do you remember what is the capacity of each shell? K shell can hold how many electrons? Just 2 electrons. L shell can hold how many electrons? Just 8 electrons. M shell can hold how many electrons? Just 18 electrons. N shell can hold 32 electrons. Okay, means you can say these are the rooms for electrons, and this room can accommodate maximum 2 electrons. This room, which is L, can accommodate only 8 electrons. M can accommodate 18 and 32 and so on. Now here we have 11 electrons. So out of 11 electrons, 2 would be in the first one. Now out of 11, 2 are in the first one. How many are left? 9. So 9, now L can have 8 electrons. So now you have 2 plus 8, 10. Only 1 electron is left, so it will go to the third shell. As I gave you an example, suppose there are 11 guests and these are the capacity of the room. So out of 11 guests, 2 will go in this one, 8 will go in this one, and only 1 will left, it will go in the last one. This is called electronic configuration. Either you write like this or you write like this. K is equal to 2, L is equal to 8, M is equal to 1, 1 and both are same. But this is better. So from this discussion, how can we summarize? We know that in an atom, there are electrons and protons and neutrons. So here we have nucleus. Look at the board. This is nucleus. All this discussion would be in this diagram. Nucleus have only proton and neutron. How many protons? 11. How many neutrons? 12. So I'll write here the nucleus has 11 protons and 12 neutrons. This is the nucleus of sodium. Then I will draw the first shell. K has 2 electrons. L, I will draw 8 electrons. And the third shell, okay? So you should know this all. From this symbol, we have done all of this and we can summarize over here. It's the summary of all of this discussion. It is telling you how many electrons are here. It is telling you how many protons, neutrons, and how the electrons are arranged in various shells. So for your practice, you can do by yourself. Fluorine 919 and might be sulfur 1632. On page number 57, you can see questions like this. Okay? Check. Here we did the electronic configuration of sodium only. Now I'll do here the electronic configuration of some elements, starting from hydrogen, but in a simpler way, in a quicker way. I will not show all of this detail. I will only start from over here, as you will see. Okay, the question. Write the electronic configuration Now see, what is the question here? Only the electronic configuration. No need to go in detail. Answer accordingly. If it is asked, find the number of protons, electrons, neutrons, you should do in that way. But here, write the electronic configuration. So we'll do in a simpler way of first 20 elements. As I told you, I will do in a quicker way. Right? This you can see in your book on page number 51, 52. So which is the first element? Hydrogen. 1. I'll keep the things simpler. 1 means it has 1 electron. Okay? It has 1 electron. So 1 electron will go in the very first shell. If I do it in a lengthy way, I will do over here like this. That atomic number is 1, mass number is 1, electron 1, proton 1, neutron means 1 minus 1, 0. Then I'll draw the structure, nucleus, 1 proton, 0 neutron, and 1 electron revolve around the nucleus. This is the, but it is not asked over here. It says write the electronic configuration. So I'm only focusing on electronic configuration. As I told you, the chart, it is neutral. Neutral means whatever number you see, 3 things you can say over here. 1 electron, 1 proton, 1 atomic number. Okay, the next one is helium. Helium has 2 electrons. So which is the first shell? K shell. Its capacity is 2. So I'll write over here K2. Now, then the next is lithium. Now, lithium has 3 electrons. Out of 3, 2 will go in the first shell, K shell, and 1 will go in the next shell. If you feel difficulty in it, just see it again and practice it. You will understand. So lithium has 3 electrons. So out of 3, K will hold 2 electrons, L, the third one will go in the next one. Then next is beryllium. 4 electrons. Beryllium has 4 electrons. So K will hold 2 electrons and L will hold 2 electrons. Next is boron. Boron has how many electrons? 5 electrons. So 2 in the first and 3 in the second. Okay. Next is carbon. An atom of carbon has 6 electrons. So out of 6, 2 in the second one, 2 in the first one. And how many are left? 4. 4 will be in the second shell. If I draw quickly over here, just suppose this is a nucleus having proton, neutron, then what would be the structure of this? The 2 electrons in the first shell, and second shell has 4 electrons. There isn't any restriction that draw electrons in pair or like this. You can draw like this also. After this, nitrogen, 7. So 7 electrons, K will hold 2 electrons, and how many are left? 5. 5 will go in the second one. So what would be the structure of nitrogen? What would be the structure of nitrogen? I'll draw nucleus over here. Protons and neutrons it has, not mentioning. 2 electrons in the first shell and 5 electrons in the second shell. Okay. Then oxygen, 8. 8 electrons. Out of 8, 2 will go in the first one as usual, and L will hold 6. Okay. And what would be the structure of oxygen? The structure of oxygen, that there will be one more electron over here. Then fluorine, K2, L7. Then neon, K2, L8. L, second shell has reached to its maximum value. Now, if there will be any other electron, it should go to the next one. We did it just few minutes ago. 2 plus 8, 10. And the 11th one will go in the M1. Then calcium or calcium, whatever you say. Then aluminum. K will hold 2 electrons. L will hold 8 electrons and 3 will go in the third shell. Then silicon, 14. K will hold 2 electrons. L will hold 8 electrons, M will hold 4 electrons. Phosphorus, sulfur, chlorine. You can do it by yourself. Just let me do of chlorine. Chlorine K2 as 8, 8 into 10 or 7. Whenever you do this, just remember two things. If you add the superscript, it should not exceed this value. 2 plus 8, 10. 10 plus 7, 17. 2 plus 8, 10. Plus 2, 12. 2 plus 8, 10. Plus 1, 11. 6 plus 2, 8. First thing. So the superscript, you can say powers, should not exceed this value because it is the maximum number of electrons.